Hi, it's DK. Today we're going to talk a little bit about binary arithmetic, stuff that Professor Mayhew had spoken to you about, but we're going to go ahead and do a few examples. Alrighty, so just as an introduction, let's see how we actually do decimal addition, okay? Just so that you see the techniques that we're going to use here very shortly. All right, so 6 plus 2 is 8 in base 10, right? And then 2 plus 3, this is in the tens place now, is 5, so it's 58 so far. And of course, this is 158. So this is in the 100 space, that's in the 10 space, and this 8 is in the 1 space. All right, great. So addition of binary numbers looks like this. So what you'll notice here right away is that 0 plus 0 is 0, of course. 0 plus 1 is 1. Okay. 1 plus 0 is again 1. No problem there. But 1 plus 1 is equal to 0, and then you carry a 1. Okay. That's the same concept as when you're doing stuff like this. 12 plus 9 plus 9. That'll give you 2 plus 9 is 11. But you can't put 11 there, so you're going to have to carry that 1. Then you want to add the 1 plus 1 over here to get the 2. Okay, so this carry is similar to this carry right over here. So let's add a couple binary numbers. There we go. 0 plus 1 is 1. 1 plus 1 is 0. You're going to carry 1. 1 plus 1 is 0, so you're going to carry 1. 1 plus 1 is 0, and you're going to carry 1. That's 1, finally. Don't carry anything here. And then 1 plus 0 is 1. 0 plus 1 is 1. And 0 plus 0 is 1. So that's the result. Subtraction for binary numbers. Similar again as what we've done before. 0 minus 0 is 0. 0 minus 1 is 1, because we're kind of borrowing from the next column. We'll talk about borrowing here a little bit. 1 minus 0 is 1, and 1 minus 1 is 0. So what do we mean by borrowing? So if I do this, 21 in decimals, okay, minus 9. This is all in decimal, base 10. Then that's, well, you can't subtract 1 from 9, at least, you know, the way we've done it. So we want to borrow 1. Okay, borrow 1 from here, so that this thing is 11 minus 9. Okay, so you want to do the 11 minus 9 operation. That is equal to 2. And this 1 is still there, so you drop that 1 down. Okay, so that's the result, 12. So that's the carry business that we're talking about. So the topic of subtraction provides a great way to talk about using this thing called 2's complement that we're going to talk about. So what we're doing is essentially adding positive numbers and a negative number. So that's the way we do it in a binary. We take, in order to subtract, we actually subtract a number, we take its negative number, and then we add the two numbers, all right? The method used to represent signed numbers is called 2's complement. In this system, positive numbers are represented as regular binary numbers, and negative numbers are 2's complement of the positive numbers. So 2's complement is formed by taking the 1's complement, this 1's complement business, and then adding a 1 to it. All right. So the 1's complement is formed by replacing all the 1's with 0. So we're just replacing the 1's with 0s, 0s, and 1's. Okay. So for example, the 2's complement of the number 04 decimal is found in the following sequence. So 04 decimal in binary is 000000100. All right. Then we're going to take the 1's complement. the ones complement says that what you're going to be doing is you're going to be inverting all the zeros to ones and ones to zeros. So now this guy right here, this 0 becomes a 1, right? This 0 becomes a 1. This 1 becomes a 0, and so on, okay? So that's the ones complement right here. Then you take the ones complement, and then you add 1 to it. That'll give you the binary representation for -4, all right? So, system also works when the magnitude of the negative number is larger, okay? When -9 is added to +8, the result is -1, of course. So what you'll notice is, check this out, this bit right here is always a 1, okay? This bit is always a 1 over here if it's a negative number. So essentially, when you're actually doing 2's complement math, your numerical system only consists of these bits, right? And that would be 2 to the 0, 2 to the 1, 2, 3, 4, 5, 6. So 2 to the 6th, okay, would be 155, okay, 155 max, or all right. So so that's the maximum absolute value that you can do with 2's complement in 8-bit arithmetic. So anyways, -9 looks like this, all right, because 0, 9 in decimal is actually equal to 0, 0, hold on, 0, 9 in decimal is equal to, oh, sorry about that, 9 in decimal is equal to 1, sorry, 0, 0, 1, 0, 0, 1 in binary, okay? So since this is, since 9 decimal is 0, 0, 0, 0, 1, 0, 0, 1, then the way we come up with a 2's complement of that will be to flip all these digits, right? So we're going to go 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, excuse me. And then you're going to add 1 to this, right? And then you're going to have 1, 1, 1, 0, and then 1, 1, 1, 1. Okay, so that is your 2's complement of 9, which is a -9, which you will stick into over here, okay? So you're going to add -9 and, to plus +8, and the result is 1, 1, 1, 1, 1, 1, 1, 1. Great. So, so we take a look at this and go, okay, so how do we convert this number right here, this 1, 1, 1, 1, 1, 1, 1, to regular binary, okay? We know it's a negative number. We know it's a negative number because the most significant bit there is a plus, okay? So plus here equals, I'm sorry, the most significant number is a 1, so 1 indicates it's a negative number, okay? So we do the reverse process. We take this result, this 1, 1, 1, 1, 1, 1, 1 result, okay? Subtract 1 from it, and that'll give us 1, 1, 1, 1, 1, 1, 1, 0, and then we take the 1's complement to that, changing all the 1's to 0's and 0's to 1's, and that gives us +1. So the last example is adding 2 negative numbers, all right? So, oops, this should be 3. I don't know what happened here. This should be 3 in 2's complement form, -3 in 2's complement form. and -4 in 2's complement form. And that should give us a -7 in 2's complement form. Now the interesting thing here is that when we add these two numbers, you actually had to carry a number up here. Okay, you had to actually carry a 1 up here. And that's your 1 down there. Now you have an 8-bit machine, or 16-bit or 32, but in our case it's an 8-bit machine. So you're only going to use these least significant 8 bits. Okay? And you're just going to discard that. Why do you discard it? Well, because it just kind of falls off the planet. Okay? Your computer, your microprocessor, if it's an 8-bit machine, only recognizes 8 bits. All right? Unless you do some other things to concatenate or basically append or put back-to-back 8 bits together, it's just going to get rid of this guy. So the largest negative number that can be represented is 128. Or -128 is a negative version of that. So what did we do in this video? What we did in this video is we demonstrated how to add binary numbers, how to subtract binary numbers, how to subtract binary numbers using 2's complement, and how to get 2's complement.